Even een big applaus voor Lisi.
Hello. Yes, I came here by train. That's what my train ride looked like. I got some coffee. There's really friendly people on the train that serve you coffee, and that's really good because I really like coffee. And there is 2 parts to coffee. So when we do animation on the web, we can compare that to coffee in a way. So we have one part in animation, and that's the user. That's how the user interacts with our interface. And the other part is the browser. We have many different browsers. We have Firefox, we have Chrome, we have mobile browsers, we have lots of different browsers. And lots of different users with lots of different experiences. And when we mix the user with the browser, we get all kinds of experiences. We get good experiences, we get bad experiences. But we can't always control the experience, but we should try to create an experience that's meaningful and that works and that doesn't annoy the user. And that's why we need to learn how to do good animation. So we need to think about who our user is. Is it a younger person where animation can be really helpful in making something more playful or understandable? Or is it an elderly person that might want to read something on their own pace and might get distracted by animation? Or someone with motion sickness that can't process animation? So we have to think who is going to view our interface and is the animation helpful in that interface for that user. So the first part of doing good animation on the web is understanding how the browser works, how browsers create animations, how we get different frames. And there are 4 things we can animate really cheaply on the browser. And that is position, so transform, translate, for example, scale, rotation, and opacity. So we can do this and animate these properties in a very, very cheap way and get a lot of frames per second. And we can do that in CSS with the CSS transform property. We can use all these different keywords. We can also chain these keywords after each other, but we have to take care in what order we chain those keywords, because they're going to end up in a different space. So if we translate something and then rotate it, it's going to be in a different space than if we rotate it and then translate it. And that is an example of animation I see a lot. So a menu that slides in from the left, and that's a really unperformant example because we're animating the left property, and the left property is a layout property, and that will cause a lot of performance issue if we animate layout properties. And a better way to animate that example, to animate a menu in from the left, would be to just use the transform translate X property, so translate something on X, and then transition only the CSS properties you're actually animating, and not all properties you're maybe changing but don't want to transition. And when we want to go in deeper to understand how rendering works, we have to look at the pixel pipeline. We have to look at what the browser actually does to create a new frame, to create a new picture. And mostly when we want to update something, we have some event or some JavaScript changes that cause some kind of repaint. And then the next part, we could animate something like width, height, left, top, whatever layout properties there are, you can animate those. But these are really unperformant to animate because we always have to recalculate all new styles. We have to figure out how much space each element needs. And that can take a lot of time. So normally we should skip animating those properties because they're really unperformant. We could animate paint properties, so we could animate CSS properties like background, box shadow, outline, all of these painting properties. But these are also not the most performant ones, and if we animate those, we cause repaints in the browser. And I will show an example of what that means in a bit. And then the most performant step in the rendering process to animate is the composite step. So animating transform or animating opacity. And because we're skipping the layout and the painting step when we're changing something, we get a lot more frames per second, because for every frame we have to go through all these steps, and if we take a lot longer on the layout step or on the paint step, we're going to get less frames per second. So try to stick to the composite step and animate transform and opacity. It's fine to sometimes try to animate other properties, but then you need to test if the performance is okay and if the animation also works maybe on a mobile device that can't process it as quick. So try to limit yourself to those, but you can do a lot with CSS transforms. And you can animate so many creative ways with just transform, which you'll see a little bit in the demos. Another way to improve the performance of your animations and make it animate better is to create new layers. So you can, in your browser, you can create different layers, like Photoshop layers. And you can create those with CSS, with, for example, the will change property, or the transform 3D transforms, like translate set, or other things like animated 2D transforms, being on top of a compositing layer, or animated CSS filters. And I created a little example that shows, is it working? Yeah. That shows how layers work in your DevTools. So there are 3 turtles here. And if I wouldn't know about animation, I might animate something like margin. And I change the margin, and then I would add a transition on that margin. And then if I hover a turtle, I can see that it's animating. But I can also see that the other turtles are changing because they are sibling elements. And then I can go to the Layers tab in our DevTools. And I can also go to Rendering and turn on Paint Flashing and the FPS meter. And now I see that every turtle is repainted whenever I hover it. So all 3 turtles need to be repainted. So now I want to do that in a more performant way and use the transforms. So I would use transform translate Y, for example, and then transition only the transform property. And now only the turtle I'm hovering is changing, so I'm not having an impact on the sibling elements. And now if I hover it, I see that every time I hover an element, I get a new layer for each turtle. But I also see if I hover the first turtle, the other 2 turtles need to be repainted. So if I want to make it really performant and not cause repaints, I would give each turtle its own layer. And now if I hover the turtles, I see they're not repainted anymore because every turtle has their own layer, and I'm not affecting any of the other layers. So layers are good for animation, they're good for performance, but we need to make sure that we don't create too many layers because every layer takes up memory, and we don't want to crash our browser, because if we have hundreds and hundreds of layers, we will crash our browser eventually. So create layers, but then remove them if you don't need them anymore. So if the animation is finished, you don't need that layer anymore. And then the last part for animation in the browser is just to use the DevTools to test your animations. So we have those wonderful performance tab where we can record different interactions, and then we get kind of a summary. And in the summary, you can already see the different colors for painting, for scripting, for loading. And by looking at those colors, we can figure out where bottlenecks might be. And in the top, you see these little red things in the performance tab. And those are areas where there could be problems. So these red things indicate that there are too little frames per second and that you might need to check what's happening there. And then we have the Layers tab to check your layers, and the Paint Flashing and FPS meter to just see when repaints are happening and if something is having an effect on another thing. And if we look at that summary, we can see that this rendering pipeline kind of translates to that summary. So when we're changing a CSS property that changes layout and animates layout, we'll get a lot more rendering than if we would animate a composite property. All right. And now we heard a little bit about how the browser works, how the browser does animation, how the rendering works. But that's only one part. Doing performant animation is only one part, because the second part is animating for the user, animating creating an animation that's good and not harming or annoying to the user. And I want to give you a few examples on how you can create useful animations that help the user in some way. And one good use case is orientation and transitions. So whenever we have an interface, we have an information space. We have different spaces where we present different kind of information, and we need to make the user understand how these different information spaces work and how they are connected. And with animation, we can help the user to understand how all the different parts of our applications are connected and why they're appearing or disappearing. So this is a little example of a website that does that. So whenever it goes to a new page, there's a smooth transition, and then slowly the new elements are coming in, and I'm having time to process what the new information space is and how that is changing, and it's not just a hard cut going to a completely different page. So doing transitions, animated transitions, and orientational animation helps the user to reorientate themselves, to understand what's happening, why something is changing, and it can also explain relationships between different elements that might be connected together. I built a little example with the Web Animations API. Who has used the Web Animations API here? Not that many, so that will be useful. It's a tiny, tiny app that just animates whenever I click a link in the bottom. So I click a link in the bottom, and then I'm animating something out, and then I'm animating the new content in. So to do that, I do that in vanilla JavaScript. I click a button, I listen to an event, then I'm animating one element out and another element in. And to do that, we need to know what's already there and what's coming in. So in every kind of transition situation, also in React or Vue, you always need to know what is going to be the next content. And in React or Vue, we have transition elements, and there we put in all the content that's going to be there. In this example, I just have 3 paragraph tags with all the content that's in there, but not all of them are visible. And then once I click a link, I animate one out and animate another one in. So I would add an event listener to a link and then call an animate function on that event of that link I clicked to know which element I need to be animating in. And then there's several steps. So I need to know which element is currently there. I need to animate that out, and I can animate that by just calling the .animate function in JavaScript on that element, on the DOM node. And then I'm giving it some animation and some timing. I'll explain that, how that works in the Web Animation API in a bit. And then I get an animation object from that animation, and once my animation is finished, my leaving animation is finished, I'm calling the next animation to transition the element in. So that's how the Web Animations API essentially works. I get a DOM node with JavaScript, and then I call the .animate function on that DOM node. And then I'm handing it 2 parameters. The first one are always the keyframes, so the stages of the animation. What do I actually want to animate? Do I want it to move? Do I want it to rotate? And then the second part is the timing object, and the timing object is there to tell you how it's animated, how fast should it be, what should happen when the animation is finished. The keyframes can either be an object, so an object with the different CSS properties, or an array with the different keyframes. So every object in the array would be 1 keyframe. So for example, 0% and 100%. And then the timings object has a lot of different things we can put in. So the duration of the animation, the iteration, the delay, the end delay, the fill mode, and these are really similar to how CSS works, to how CSS animation works, because they work really closely together. So if we look at a simple CSS animations, we define that with the keyframes keyword and then some animation. Here from 80 to 100%, so it's not a linear animation. And then I'm defining the animation on the element. If I wanted to do the same thing in the Web Animations API, it's not that much different. So first I define the keyframes in my array. Here I can define an offset, so that's the equivalent to the 80 and 100% would be the offset of 0.8 and the offset of 1. And when I define my keyframes, I need to define the timing. So I want the animation to take 500 milliseconds, I want it to run twice, and it should have the following easings. And these are all the same keywords we use in CSS. So they work really closely together. So in our example, the example you saw in the beginning with the little app, I'm defining a leaving animation where I'm animating the transform translate y. So I'm moving something on the y-axis and the opacity. So I have 0% translate 0 and opacity 1, and then when it's leaving, it's translating to 40 pixel and becoming invisible. Then the second part is defining the timing. So I have some duration, I have easing, so in this case a sine easing, so I can use cubic Béziers to do that easing of the animation and the fill mode. And then I just call that on the element I want to animate, so on the main content I'm animating. And whenever I call the .animate function, I get back an animation object, and on that animation object, I can call the onFinish function and call another animation. Whoops. Does it work? Yeah. And now that's the example we built. That's the wrong video. Okay. There should be another video here. What I wanted to show is that you can customize, you can make your animations a lot more dynamic by using functions. So the Web Animations API gets a lot more powerful when you make your animations dynamic and reactive. So in this case, I can return the keyframes array with a parameter. So I'm defining a function that's x, and then I'm translating x depending on what input I give to that function. And then whenever I click a button, I would hand a different x value to that function, and so I get different animations. And I think here we have the right video, hopefully. Yeah. So in this example, I give a different x value to the animation, to the keyframes, and that causes this animation to go left, right, or down, depending on which button I click. And that we can do really easy with the Web Animations API. In CSS, that's a lot harder to do because I have to define a lot more different classes and animations and hard code that and can't make it as easily dynamic as I can do with pure JavaScript. And why is the Web Animations API there? Why did they create the Web Animations API? It's a native API by the browser. We don't need to load external JavaScript libraries to do animation, but we can do more powerful animation. We can react to JavaScript events, and we can also render animations over the compositor thread. So we don't have to render it over the main thread, but we can render it like CSS animations do over the compositor thread, which is more performant. And then we can create choreographed and chained animations, which is also kind of hard to do in CSS if you have 10 different steps in the animation, because it gets really long. And in general, it's just a native, more powerful alternative to CSS. But when I just asked if anyone already used the Animations API, really few people did. And that's because it's still developing. So back in June, I was at a conference and I presented this slide because people want to know, can they use this API already? And there we can see the major browsers are kind of there, it's all green. Safari is also there. But then when I checked again a few weeks back in October, Safari turned red again. So it's not available in Safari at the moment. You can activate it under the experimental flag. But that doesn't mean it's not going to be in Safari. If we look at the Web Platform Tests website, we can check how far along the browsers are in the implementation. We can see that Firefox already implemented all of it. So Firefox is kind of done in implementing the API. And Safari is halfway there. So they're still working on it, on implementing it, but it's going to be in Safari. And I checked the Web Animations Slack to see what the people there said to that development of Safari still working on it. And there was one person that asked, does anybody ever use the Web Animations API? And someone who was working very closely with the different browsers to implement the API said that Safari is getting pretty close on implementing it, it's making good progress. And it's already on major sites like Google Play with polyfills. So you can load a polyfill and then use the API. And that already shows that it's going to be in the browsers pretty soon, that the browsers really want that feature and the browsers are implementing that feature. So we can already start learning it and playing around with it, and we can already use it if we load the polyfill for the API. And another good use case for animation is attention and feedback. So whenever we want to give some feedback to the user, we can use animation to do that. Rachel Neighbors wrote a great book that's called Animation at Work. And she said that feedback indicates causation between two or more events, often used to connect the user's interaction with the interface reaction. So whenever a user is doing something, I'm giving feedback to the user, I'm showing a reaction on what happened. That could be in the form of showing an animation when we click a button, showing that we recognize that someone clicked a button, or showing that something is not correct in a form, animating a color or some different animation to show that there has been an error, or to making system activity visible, so to show that the system is working on something, you send a request, the system is processing it, and while that is happening, you're showing some loading animation. Here's a code band that shows that really well. So we're entering some input, and if it's invalid, it turns red, and it has this wiggly animation to really grab your attention and show that there's something wrong. And if it's right, it turns green and shows that it's correct. So that's a really simple form of micro animation that's very useful to the user. And then the second part, attention, is to show possible actions. So we can use animation to make the user aware that he can click somewhere or that there is an important step he should be looking at. So motion always attracts the user's attention. And we can also use animation for storytelling. So we can show little tutorials. This is very popular in onboarding situations. While you fill out things, you get little animations and tutorials showing how that could work. And we can also use it to add more fun and reinforce the branding of an interface. Stripe is really good at that. So Stripe has a lot of micro animations in their website that just grab the attention and make the user interact more with their website. So they have these tiny interfaces that kind of animate and that you can click. And that really grabs the attention of someone and makes them stay longer on this site because it's more interesting and more fun than just text. And for that, I built another little example with reactive animation. So what is reactive animation? Reactive animation is one that involves discrete changes due to events. That is something Connell Elliott described in a paper he wrote in 2007, that's called functional reactive animation. And he's also really great at building personal websites. He has this lovely little GIF on top of his website. I think it's a really good use case of animation. It makes it a lot more delightful. So let's look at the last example. JavaScript and CSS variables are a really good combination for animation. So I built a final demo with those two. And we can use them in JavaScript. So in JavaScript, we can get elements and we can set variables on all those elements with the setProperty function, and then the name of the variable and the value of the variable. And then in CSS, we can use all those variables we set in JavaScript with the var keyword. So we could, for example, in this example, translate x depending on that x variable we set in JavaScript, and rotate it depending on that rotation variable we calculated in JavaScript. So here's the example I built. So it's the script logo that reacts to mouse move. So I'm moving my mouse around, and it changes the hue. It also changes the rotation. And most of it, all the animation parts are done in CSS, but the calculations of the mouse events are done in JavaScript. So here I added the years of script. In 2017, it was yellow, 2018 too. Now it's really red. It's very, very red. It changed a lot this year. And I added a little example for 2020 I would think worked great. We're almost there. We're almost there. That would be great, no? So let's look at how we can build that. So to work with JavaScript and CSS variables, we first have to get that logo, get that element. And then we are also creating a variable called rough. Some of you might have seen it before. Rough is the shorthand for request animation frame. It's in a lot of animation JavaScript you might encounter. Then we're listening to the event, so we're listening to the mouse move event. We're calculating our x and y values we're going to use in the CSS. And the x and y values in this use case are just going to be a value from 0 to 1, depending if the mouse is on the left or on the right, or on the top or on the bottom. And then we're calling an update function, but we're calling that update function inside the request animation frame. So we're updating our DOM whenever we're able to have a new frame. So how request animation frame works is that we have a lot of different frames. And we continuously want to update whenever we have a new frame available. So if we call an update function with the request animation frame function, it will update our changes before each new frame. What that means is if I have a mouse move event, then it would update here before this frame. If I would have a mouse move event here in the middle, it would update there. And the reason why it's good for performance is if I have 100 events and I can't handle them, I update only the latest event that I'm ready to update before the next frame. So I'm only calling the update function once, even though the mouse move event happened 100 times. So that makes it more performant for the JavaScript part. And then in my update function, I'm just sending the x and y value to that and just setting the variables. And then I have some other function that just calculate a hue or a lightness depending on the value of x or y. And in the end, I'm resetting the request animation frame to be able to call it again. But now we haven't defined what is animated. So we haven't animated any transforms or colors. So we need to update our CSS to use our variables. We can do that with, so in this example, I did it with Matrix 3D. Who has used Matrix 3D before? Two people? Yeah. There's also only Matrix, but most of people don't know about Matrix 3D. So they don't understand what it is, and they don't really want to use it. And when I saw it the first time, I was like, how does this work? How does Matrix 3D work? It kind of reminded me of my computer graphics classes, but Eric Meyer got you. He built a little tool that helps you to understand Matrix 3D. And that's that. That's a matrix resolution tool you can find on his website. And what you can do there is you can add simple transforms, like a translate X and a translate Y. And you need to spell it right. And then you can click the red pill and you get a matrix back. So that's pretty cool. You can also add other transforms and click the blue pill, and then it's all gone. And we're really sad. But the Matrix 3D, it's kind of complicated because it kind of combines rotation, translation, scaling, perspective, all of these CSS things that are kind of easy to understand in one single property. So we can have translation matrix by changing these values. We can have rotation matrix by calculating the cos or sine of something. We can scale it, we can rotate it, we can do a lot of 3D transform with the matrix. And the reason I sometimes use it is because if you use the matrix function, you don't need to set a perspective on the parent. So that's the simple and very understandable way of writing a rotation. And so to rotate something in a 3D space, we need to have a perspective on the parent. And if we don't want to set that on a parent, we can use the matrix 3D to do the same rotation just on that element. So in this case, I'm just rotating it on that element. And if I wouldn't add the perspective, it would look like that. So it wouldn't be a 3D transform. All right, so that was the example. Why is JavaScript with CSS really, really powerful? It's really easy to debug because you can always look at what your variables are and what values they have taken on. And what the really great part about it is that we don't have excessive DOM manipulation. So we don't need to set that transform on every element in JavaScript. We can set it once on a parent and then use this variable in all child elements in CSS. And that's really good for reactive animation because I can set one variable X and then change the color or the transform or the background depending on that variable just in CSS. And we can also transform individual properties. So in the beginning, I told you that you can chain different transform properties like translation, rotation. And before we had those variables, it was a lot harder to update those transforms because you would always need to write all 5 transforms you were using. But now you can just use a variable inside those individual transform properties and then update only the translation or only the rotation by just updating that variable. So that now it's a lot easier to update transforms with the CSS variables. All right, let's move on to the last part. I want to tell you really quick how timing and easings works because a lot of people are kind of confused how quick the animation should be, what an easing is. Most of people use ease out or ease in, but they feel uncomfortable about using other easings. There's a really great article by Valhead, who also does a lot of web animation. And she says that 0 to 200 milliseconds are really great for small changes, for fast changes like hover effects, fading, scaling, and small distances. But then if you want to have slow transitions, you should take longer timings, like 300, 400 milliseconds, because then it doesn't attract as much attention and it's slower and less distracting. And then for easings, we have a lot of basic easings we can use in CSS. There's a website called easings.net, and it has the simple easings like ease in, out, sign, or ease out, circ, and these make your animations a lot more interesting by using easings that are not the main ease in, ease out. And then we have more complex easings, and we only can do those in JavaScript. So whenever this curve gets a lot more complex, like a bouncing or an elastic easings, we have to use JavaScript to calculate those. And in general, ease out, so for example, ease out sign, feels more reactive and instantaneous because it starts off quick and then slows down. We can see that in the curve, so it's more quick and then it slows down. It gets not as steep. And if we have really complex easings, like a bouncing easing or an elastic easing, we need to give that easing more timing. So we need to make it 500 milliseconds instead of 200 milliseconds because that easing is quite complex and takes longer time to process. And when we animate elements in, so from outside of the screen into the screen, we should pick an easing that starts quick and slows down towards the end when it's there in the screen. So an ease out sign would be maybe a good easing we could choose. And when something is leaving the screen, it should start slow and then get quicker towards the end, so leave quicker in the end. So then an ease in sign might be the right choice. To recap, there's a lot of different things we can use animation to make it useful for the user. We can make idle times more useful and interesting. CSS loaders, for example, are a good use case when you don't have your content yet and you need the user to wait for that. We can guide the user in a process, use onboarding animations, or little animations while he's waiting, or she. And we can explain relationships in the information space, so use animated transitions to show we're moving from A to B, or to show that some element is connected to another element. And we can get the user's attention when we need it, when he committed an error in a form, or when he really should move to another part of the application. If you want to learn more about animation, there's a lot of great resources. So there's this book by Rachel Neighbors that also explains how to prioritize animation in your clients' projects and in your teams, because it can enhance the user experience and the usability of interfaces. There's a really cool live coding Twitch channel that's called Keyframers, and is also on CodePen, so all the examples are on CodePen and you can look at them. There is the Slack channel I already mentioned, where people discuss all different animation topics. And the Google fundamentals are always a good place to start to better understand how to do performant animation, how the rendering works, and all those kinds of things. And in the end, most animations don't need to be noticeable. So users should only notice your animation if you need to attract their attention in that moment. Otherwise, micro-interactions and maybe transitions should be so seamless, users don't even notice that there is an animation. So often the best animation is the animation you might not even notice, because then it's not distracting the user and it's not keeping the user from doing something. And that's also from the Animation at Work book. So in the end, you should animate for the user and not create obstacles, and think about who is using your interface, and how you can make your interface more usable for those different users. Yes. I'm a lecturer at the University of Applied Science in Salzburg, so you can come study with me in Salzburg. I have a blog where I occasionally blog about animation, and you can talk to me on Twitter if you want to. Thank you.